Hi there, and welcome back to PHP Security Pitfalls. In this video, we'll tackle a particularly nasty security pitfall, namely SQL injection. Now, security experts have warned developers to protect their applications against SQL injection for over 10 years. But still, SQL injection attacks are very common, as is SQL injection vulnerability. Injection, which SQL injection is part of, is still on OWASP's top 10 web application risks for 2013. So, what is SQL injection? It's time to do a little modest hacking of our own. Okay, let's say we have a small blog application with some users and some posts. I'll just create a folder for that and call it SQL injection. And then I'll just switch to SQL Pro and add some tables for our project. First, let's create a users table. We'll set the encoding to UTF-8 and the table type to myISOM. And then we'll also need a posts table, and let's set that to the same settings as well, like so. Now our post table will contain a user ID, which will be a foreign key to the users table, and that should be an unsigned integer. Next, we need a title, which will be a varchar of 250, I think. And then last but not least, we'll need a body, which will be a text field. Then it's up to our users table. All we need is an email address, and that will be a varchar of, well, 100, and it cannot be null. And then we'll also need a password, which will also be a varchar of 40 characters because we'll SHA encode all the passwords. Okay, let's add one or two users. We'll start with Joost at joostvanveen.com. And we'll just use a password of tuts+ and make sure that we hash it to a SHA-1 value. And then let's add another user, and his email address will be chucknorris at tutsplus.com, and he'll have a password of Chucky, and that will also need to be hashed into a SHA-1. Now for our post table, let's just add a single post. User ID should be 1. Title will be my first title or something, and the body will just contain some Libsyn text here. And that should do for our database. Now let's try and perform some SQL injection into this table. First of all, we'll go to our editor. And let's create a fairly common page. So let's say it's one where we enable our users to reset their password. And to do that, we'll create a new PHP file and call that reset.php. And you know what? Let's create another file as well and call that PDO, because we'll be using PDO extension to access our database. Okay, first things first, let's require that PDO file. And now we're ready to add a function here. And we'll just call that connect. And we do need to make sure that we spell it correctly. Now what this will do, it will return a new PDO connection. So that's a new PDO. So set up the host first. That would be MySQL. Host would be, localhost. And the username would be Joost van Veen. And the password would be tuts+. Now we can also add an option, and let's do that, because I would like PDO to throw an exception. So we'll set the attribute error mode to PDO error mode exception. And this basically means that if PDO encounters an error, then it will throw a PDO exception, like so. Let's just clean that up, and that should take care of our connection. Now here what we want to do is send a reset email to a certain user, and we'll need his email address for that. So we'll just mock the email address and pretend that it was given to us through a form or through the URI or anything. So we'll do Joost at joostvanveen.com. I think that would be good. And we'll create a query. That query will read select all from users where email equals, and then we'll add in 2 single quotes and pass in the email, like so. And I'll tell you what, it would be nice to see what kind of SQL we're actually using. So let's just do 2 paragraph tags and pass in the SQL right there. Oh, sorry about that, SQL. There you go. Okay, now in order to be able to set a reset email, we need to know if the user actually exists. So let's do a try and catch block and see if we can find that user inside of our database. First, we need a PDO connection. So PDO equals connect. And now we can prepare a PDO statement. So we'll do query equals PDO statement or prepare statement. And we'll just pass in our SQL here. And I'll just fix this typo here. And now that we have a statement, we can run it by doing query execute. And then we'll fetch the actual user using the fetch method, and we'll store that user inside of a user variable. Now this is where we would normally set up a password reset email. And then a lot of applications would do things like echo to the screen, something like a password reset email has been sent to, well, whatever email address we got from. Well, if something goes wrong, we could catch a PDO exception like so. And you would be surprised, but a lot of applications actually echo this to the screen. We'll just do echo get message here. So in retrospect, we have a connect method here that connects to a database. Oh, I forgot the database here. Okay, I'll just do that. DB name is, let's see, SQL injection. But anyway, it connects to a database and returns that connection. And here we set up a query trying to fetch a user based on an email address. And this is where we actually execute the query. Now let's see how this behaves in the browser. Well, as you would expect, this is the actual query being run, and we see here that a password reset email has been sent to joost@joostvanveen.com. Well, it would, wouldn't it? Because we didn't build in a safeguard. You see, we should only run this code if we actually obtain a user from the database. So we'll do an if statement here and just say that if the user does not equal false, then we'll actually run this code like so. Check it one more time. Yes, a user was retrieved from the database. Let's just change this email address just a little bit. And here we don't get the send message, so that means the user could not be retrieved. Well, that's all fine and dandy, Joost, I hear you say, but what does it have to do with SQL injection? Well, we'll come to that now. You see, this code is prone to SQL injection. Let's say we didn't receive a valid email address, but we just received a random string like any value. Now that would get us nothing, of course. Now let's see what happens if we append any value with an apostrophe. Then we get this syntax error here that says we have an error in our SQL syntax. Now this error will tell us that the code we are using is prone to SQL injection. And we know that because we could actually change the entire query by just changing the value we passed. Now let's see if we can turn this into a valid query, but a query that will always return a result. We'll try and do any value or 1 equals 1. And note that I am leaving out the last apostrophe. Okay, it's back to the browser and refresh. And here you can see the password reset message. And that means we actually retrieved a user from the database using this query. And that's because we passed this value here. And that changed the query to saying, okay, get me a user where the email is any value or where 1 equals 1. Well, 1 equals 1 is always true, so it will always fetch a user. Let's do a double check and see what user we actually got the email address from. So that would be user email. Let's refresh the page, and it has been sent to joost@joostvanveen.com, and that's because that's the first user in the table. Now let's see what else we can use this vulnerability for. We can actually find out the table names just by changing this setting here. Instead of 1 equals 1, I'll do members email equals 1, and this will assume that we have a members table in the database. Let's see what that does. Refresh it. And here we get a very helpful message saying we don't have a column members email. Okay, so let's try users email. And the error message is gone. That means that the table name is users. But we can do more. Let's try and fetch the very first email address from the users table, where email does not equal 1. Now this should give us the email for the first user in the table. And yes, it does, joost@joostvanveen.com. And now we'll do something called stacked queries. We'll just end this statement here with a semicolon. And then we'll do update users, set email to, I don't know, Darth Vader @thedarkside.com. where email equals joostvanveen.com. I fixed that typo there. Let's see if that works. Well, as you can see, we get 2 valid SQL statements, 1 and 2. Let's see if it actually changed something in the database. And there it is. The first email address has indeed been changed to Darth Vader @thedarkside.com. And now what I could do, of course, is just fill out the password reset form and have the password reset email be sent to my actual own email address. then I could sneak into the application as an administrator and do all kinds of dodgy stuff. But it doesn't end there. Using stack queries, I could do any value and then just actually drop the entire table users. And I would have to append that with 2 dashes, which makes for a MySQL comment. So if I refresh the page now, you see that I've altered the query into drop table users, comment, quote. Let's go over to SQL Pro, and indeed our entire users table has been dropped. Well, I think we can safely state that SQL injection is not for the faint of heart. But what can we do about it? Now, the first thing is data validation, of course. This code here should never have been run in the first place. Data validation should have pointed out that this was tainted data. Now, that should have been our first security layer. Our second security layer might have been escaping the data. PDO, MySQL, and a whole lot of other database layers have certain quote methods that you can use to prepare escape values with. With PDO, we could do PDO quote, and then I could just pass in that email variable there. Now, while that would make it more secure, this is considered bad practice, and I'll tell you why. It's because you have to quote each and every statement always, all the time. So you're bound to forget it once, and once is all it takes. So the best thing to do is bind your parameters. So how do you do that? Well, first of all, you do not pass in PHP variables directly into your SQL string. Instead, you pass in a colon and the name of the placeholder. Then you prepare your statement just like you did before. But the next step is to bind your parameters. So we'll do query bind param. The first parameter will take the name of the placeholder, and the second parameter will be the actual value. So in this case, that would be the PHP email variable. Now you can also pass in a third parameter, which will tell PDO that this is a data variable of a certain type. So what we'll do here is PDO param underscore string, and that will tell PDO that we're dealing with a string here. And that's really all there is to it. Now we're almost ready to see if that works. See, we still have the malicious code that we're injecting into this query string here. But first we need to restore the users table because we just deleted that. So I'll just run a query here to recreate that table, and we're good to go. Open up the browser and run that guy. But how's our table holding up? Let's just open up our SQL Pro and refresh here. And as you can see, all the users are still in there and the users table is intact. But let's make sure the code also works if we pass in a valid email address. So that would be joost@joostvanveen.com. And indeed, joost@joostvanveen.com has been retrieved. In short, we have indeed successfully fought SQL injection by binding our parameters, even though we didn't validate the input and even though we didn't escape the input when we passed it to the query string. In a real-life application, this would be considered bad practice because remember, we have defense in depth, so that's security layer after security layer. Well, the first security layer is validate your data and abort if it's not valid. The second security layer is bind your parameters, like so. And then of course it wouldn't hurt to do some escaping as well. For instance, if you're saving data that's not supposed to contain HTML, you could do HTML entities just prior to saving it. But we'll talk about that in a later video as well. Oh, and as an extra part of escaping, don't forget to typecast your variables like we discussed before. And of course we should also have applied the principle of the least privilege. Don't forget to never grant a database user more rights than he needs to complete his task. This user should never have been able to drop the database. Okay, I'll leave all the SQL injection code in the source so you can download it. In the meantime, code safely, and I'll see you in the next video.